Okay, and this is question 3 from the second worksheet. So it says brick of weight 10 newtons. So again, hasn't given us the mass. I don't know the mass, and it's M, but the weight is 10. So the weight goes vertically down. So 10 goes down, lies on a rough plane. So that means there's a mu involved, coefficient of friction, and an angle of 30 degrees to the horizontal. So there. A horizontal force of 12 newtons acts on the brick, and the brick is in the point, is in equilibrium on a point of slipping up the plane. So it's about to start going up here, but at the minute, it's in equilibrium. So as it's on the point of slipping, friction must be its maximum. So again, we can use this equation, friction equals mu times r. If it wasn't on the point of moving, remember that would be less than or equal to. And we first of all want to find out what mu is. Well, same thing as before. I'm going to have my normal going that way. It's on the point of going up the plane. So that means we're going to have friction trying to pull it down the plane. Now this time, this is my vertical direction. This is my horizontal. So I've got two forces we need to split up this time. I've got the 12 and the 10. So 10, I'm going to do down and to the left. So that's 30. So this bit here is adjacent. That's 10 cos 30. This bit's opposite. That's 10 sine 30. This 12 here, well, can you see dead angle? So this is 30. So that bit there must be 30. So I can split 12 up. It's going to look messy with friction. I'm going to get rid of the friction for a minute so you can see it's going to go down towards the slope, then up the slope. And this bit here is opposite. There's going to be 12 sine 30. And this bit's adjacent, so it's 12 cos 30. And in fact, I'm going to put friction on this bit instead. Yeah, so I've got all my forces on now at the angles I want them. So again, now it's just using F equals ma. Since there's no acceleration anywhere up the plane or perpendicular, I can just do up equals down and up equals down. So if I first of all just do this way, so F equals ma that way, I'll get R. It's the only one going up, and that equals 12 sine 30, because that's going down, plus 10 cos 30, because that's going down as well. If I do F equals ma going up the plane, I have 12 cos 30, that's going up, equals, well, I've got 10 sine 30, because that's going down, plus friction, because that's going down as well. Okay, now I'm going to end up using this formula, so I want friction to be by itself. So friction equals 12 cos 30, take away that 10 sine 30. Okay, now sub both of them into this one here. So we get friction, which was 12 cos 30, take away 10 sine 30 equals mu times r, which is this one, 12 sine 30 plus 10 cos 30. To get mu, just divide by that bracket. So I'm just going to divide by the r log. So mu is the friction. Divided by the r, which was 12 sine 30 plus 10 cos 30. Just type that in your calculator. Mu is 0.3678. So the three significant figures, 3, 6, 8. Again, no units for coefficient of friction. Now, this one combined both the skills log because I needed to tilt my paper to make this horizontal, and I also needed to split this force up into a bit down and up. Okay, now it's asking if we take away the 12 newtons, will it actually start sliding down the plane? So let's get rid of this. Actually, in fact, I could have just done this, couldn't I? Get rid of that. And this time, if it's want to go down the plane, friction is now going to go this way. So my mu stays the same, but friction will change. And 3, 6, 8. Right, okay, so acceleration could go this way this time. Okay, so first of all, work out the new R. So R just equals this. There's no other vertical force this time. So R equals 10 cos 30. Now I'm then going to times it by my mu to get what the maximum friction can be. This one's less than or equals to, so I don't know if it is moving or not. So it's equal to 0.368 times 10 cos 30. I'm going to type that in my calculator. So I've got friction is less than or equal to 3.185, goes on forever. So that's what the maximum this can be. Well, let's look at what 10 sine 30 is. 10 sine 30. Well, this is 5. So if 5 is trying to pull it down, friction can be anything up to 3.185. So 5 is stronger than this one. So therefore, 5 will win, and 5 will make it slide down. So it will slide down the slope. So acceleration bigger than 0. So friction will equal this. And I guess if you wanted to work out the acceleration, you would do 10 sine 30, take away friction, equals the mass, which you have to work that out by doing 10 divided by g, and then rearrange it to get there. Although the question just asked, will it move? And it will move because this is 5, and that's less than 5.